So we want to talk about the GPIO pins of Raspberry Pi 4. Um, Now when you look at Raspberry Pi 4 board, what you can find is it has 40 GPIO headers, like you can see here, and then and other ports. So our focus on this very video is how the GPIO pins can be used. How do we work with the GPIO pins of the Raspberry Pi 4? So um, we're going to do a very basic project to start with. We'll be doing a blinking of an LED on this video to enable us to have a better understanding on how the GPIO pins works. So most models of the Raspberry Pi have a 40 pin header shown in the image above. So of the 40 pins, 26 are GPIO pins and the others are power or ground pins plus 2 IDE EEPROM pins, which you should not play with unless you know your stuff. Any of the GPIO pins can be designated in software as an input or output pin and used for a wide range of purposes, whether it is turning on an LED, driving a motor, or sending data to another device. The possibilities are almost endless. GPIO pin numbering. So we are going to talk about the GPIO pin numbering. How will you know pin 1, pin 2, and all of that? So when programming the GPIO pins, there are two different ways to refer to them: GPIO pin numbering and physical numbering. Throughout this course and all our resources, we will refer to the pins using the GPIO numbering scheme. So these are the GPIO pins as the computer sees them. Looking at them here, you can see the ones in yellow circles are GPIO pin numbering, while the one in black is the ground or the negative. The one in orange here is a 3.3 volt, so it has two 3.3 volt points. Then the one in right here is 5 volts. Then the white one here is the EEPROM. So let's look at the pinouts. You can see we have pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that way to pin 40. We also have GPIO2, GPIO3, 4, GPIO17, 27, 22, like that. Now, when programming the GPIO pins, how would you know if you are meant to use GPIO2 or you're going to use 2 this way? So let's look at the pin numbering convention. So there are two kinds of input output pin numbering for the Raspberry Pi. One is a BCM and the other is baud. BCM is Broadcom. That means it's very linked to the chip. So basically these pin numberings are useful for writing Python script for the Raspberry Pi. So the GPIO board, this type of pin numbering refers to the number of the pin in the plug. That is a number that's printed on the board. For example, Pi. The advantage of this type of numbering is it will not change even though the version of board changes. So GPIO board. So you can use the board numbering convention or you can use the BCM numbering convention. So the board numbering convention doesn't change as the version of the board changes. For instance, looking at this numbering scheme, you can see that 1, 2, 3, 4, 5, 6 to 40 here cannot change, but these other ones here can change. So this numbering system in white circles here, they are referred to as the board. That's the GPIO board. Now the GPIO BCM, the BCM options refers to the pin by Broadcom SoC channel. So significantly the Broadcom SoC channel designation. The BCM channel changes as the version number changes. So let's look at, so now if you want to refer to the pins with the numbers represented in circles, this 1, 2, 3, 4, you'll be referring to them with GPIO pin.baud. So GPIO pin.baud are these ones, 1, 2, 3. These ones in circles here, that's the numbering that works for them. Why? Now if you want to refer to the pins with the numbering represented in rectangles, these ones here where you have GPIO2, GPIO3 in rectangles this way, that's when you talk about GPIO.BCM. So you need to know these two numbering conventions so that you don't get confused during programming. So the BCM numbers changed between versions of the Pi Model B, and you will need to work around. So it may be safer to use the board numbers if you are going to use more than one Raspberry Pi in a project. So as you can see here, this is it. This is the GPIO pins. Can you see that? So 1, 2, 3, 4. This one here are the board, while these ones here are the BCM. Now the next thing we're going to talk about is the voltage. Unlike Arduino Uno that works with 5 volts, and then the inputs and output pins of the Arduino is 5 volt, for Raspberry Pi it is not 5 volt, it is actually 3.3 volts. So the voltage of the pin is labeled on the reference guide. So there are 2 5 volt pins and 2 3.3 volt pins, as well as a number of ground pins, which are unconfigurable. The remaining pins are all general purpose 3.3 volt pins. Okay, so it means that all the GPIO pins of our Raspberry Pi are actually 3.3 volts. Very important. So what it means is that when you're using the Raspberry Pi GPIO pins to work as an input, you have to ensure that the voltage going into the pins of the Raspberry Pi does not exceed 3.3 volts. It must not be more than 3.3 volts. Yeah. So the threshold is that. So one other thing you need to know is that the Raspberry Pi sees a voltage between 1.8 volt and 3.3 volt as a high or a 1, while any voltage below 1.8 volt, it sees it as a low. So we're going to do a very basic project here on how we can blink an LED. So let's get started. How we can blink an LED. So the components that we need to blink an LED, we have our breadboard, we need our wires. So we need our wires. We also need our LED. So we have 3 LED and 3 resistors here. So we're going to be working with this. Okay, so first of all, we need to install ROPI.GPIO on our terminal, on our Raspberry Pi. So this library is needed for us to be able to work with the GPIO pins. I'm going to first of all connect remotely to my Raspberry Pi. I want to believe you know how to do that, so just watch me do it. So I'm going to open my IP scanner to scan the IP address of my my Raspberry Pi. First of all, I need to confirm my gateway to be sure that I'm currently scanning the right. So I'm going to type ipconfig on my CMD. So currently it's more like my laptop is not connected. My laptop is not connected. So I'm going to connect to kinematics network name. Okay, so I'm connected right now. So I'll go back to my IP scanner here and also my CMD to reconfirm what my IP address is. ipconfig. So my IP address is this, I see that, and my gateway is 43.1. So it means that when I'm scanning, I'm going to start from 43.1 and then scan to an endpoint. So I'm going to start my scanning. So it's currently scanning. So we are trying to look for a Raspberry Pi in the network. We're trying to find the IP address of our Raspberry Pi. So we're still scanning to find what the IP address of our Raspberry Pi is. That's it here. The Raspberry Pi is one of the device connected to the network. So you can see the current IP address: 192.168.43.140. Cool. So this is what we're going to work with. So I'm closing my CMD. I don't need it. So I'm going to open my VNC, So VNC viewer, that's it here. So my VNC viewer is here. So I'm going to type in the IP address I just saw now, 192. Sure that we type the same IP address that we have here. So 192.168.43.140, enter. So username is pi and the password is raspberry. Then okay, that's it. So we are in. Currently we are in. We are in. So the Raspberry Pi is connected to the same network as my system. It's connected to the same exact network. Okay.